Next, we'll look at the nature of our roots without using a calculator. That's called Descartes' rule of signs. So what happens here in Descartes' rule of signs, I count the number of sign changes. Anytime it changes from positive to negative or negative to positive. And the number of positive real roots is going to be the number of sign changes I have, or less than by an even number. And for a negative number of roots, I'll count the number of negative sign changes, or less than that, by an even number of roots. It sounds pretty complicated, but actually it's a pretty simple process. So let's take a look at example 3 here. First, we'll start with our positive roots. I'm going to count my sign changes. So what happens? I'm going from x to the 6 to x to 3x to the 5th. I'm going from positive to positive. That doesn't change signs. Well, then I look at, I'm going from positive to negative. There's one sign change. Then I keep on going. It stays negative, and then it flips from negative to positive. So that's my second sign change. And then it goes from positive to negative. So there's my third sign change. And it goes from negative to positive. So I get 4 sign changes. So my number of positive real roots is at most 4. So I could have 4 or less by an even number. So 4 or 2 or 0. I might have no real positive real roots. Now let's look at our negative real roots. Well, the first thing for your negative real roots, you have to look at f of negative x. So what I'm going to do is I'm going to evaluate f of negative x. So what happens when I replace x with negative x? Well, if I take negative x to the 6th power, in fact, I think I'll write this down here so you can see it. So I have negative x to the 6th power plus 3 times negative x to the 5th power minus 4 times negative x to the 4th power minus 6 times negative x to the 3rd power minus 8 times negative x plus 5. Now let's simplify that. If I take negative x to the 6th power, that's x to the 6th. If I take negative x to the 5th power, that's a negative, so I get minus 3x to the 5th power. And then minus 4x to the 4th power. I just noticed I put my exponent to the wrong point there. That should be outside the parentheses. Okay. Plus 6x to the 3rd power, because a negative cubed is a negative times a negative makes it positive, plus 8x, and then plus 5. Now let's count the sign changes. So here's one sign change from positive to negative. And then I'm going to have from negative to negative stays the same. Then I got negative to positive. There's another sign change. And then it stays positive. So I have up to 2 negative real roots. Or, when I say 2, that means I could have 2 or 0 real roots. Now let's make a table for the nature of our roots. So what I'm going to have here is I'm going to have positive, negative, and complex roots. So if I have 4 positive real roots, notice I have a total of 6 roots. And let's say I don't have any negative roots. That means that I have to have 2 of those would be complex. If I have 4 positive roots, I could have 2 negatives, then I won't have any complex, would I? And then let's look at 2. I could have 2 positives, but the maximum I can have are 2 negatives, so I'd have 2, so that would give me 4 complex. And then 2 are 0. Well, hold it. I bet I can't add. 2 plus 2 is 4, so I'd have 2 there. Now if I have 2 and 0, then I'd have 4. Now I kind of run out of room here. I could also have no positive roots, and I could have 2 negative roots, which would give me 4. Or I could have no positive roots, no negative roots, and 6 complex roots. So we just look at the different variations of that. And what happens, we would use this, and then we use synthetic division to find out what we have.